Okay, so the final topic in this chapter is on the electromagnetic spectrum. Honestly, you've probably seen this before, but we might see a couple of new things. First of all, the speed of light are related by the wavelength and the frequency of the light. So the speed of light is given by the lambda times the frequency. Lambda is in meters, and frequency is in 1/seconds, or hertz. So wavelength has SI units of meters. Frequency has SI units of the hertz, after Heinrich Hertz, and this is equivalent to a 1/2. Just remember on your waves, we haven't covered waves in a while, but waves look like this. The wavelength is the distance from here to here, so that's one wavelength, and the frequency is the inverse of the period, and the period is the time for a wave to travel one full wavelength. If we look at the spectrum of the electromagnetic spectrum, it has a wide range, of which the visible spectrum is only a small part. That goes from low energy, so this is a low energy, to high energy, from radio waves to gamma rays, with the visible spectrum somewhere in between. This would be long wavelength. Radio waves are very long wavelength, while gamma rays are very short wavelength. In fact, gamma rays, we don't even talk about their wavelength. We talk more about their frequency. And so gamma rays are very high frequency, and radio waves are very low frequency. And so we don't usually talk about radio waves frequency. We usually talk about their wavelength. So in between, we have radio waves, microwaves, infrared. That we would call this, actually they call it optical infrared. We would usually call this near infrared. The ultraviolet, X-rays, and gamma rays. So you need to be familiar with those. Radio, microwaves, infrared, near infrared, the visible spectrum, of course, the ultraviolet, X-rays, and gamma rays. And you should sort of know the order of those. I expect that many of you have seen that before. Here's a clip. We're actually not going to watch the Predator clip, if this is one much better. There's some guys messing around with an infrared camera. So a lot of the objects that we study are that are in the world, they emit at different wavelengths. And one common thing that emits at a different wavelength is the human body. And the human body actually loses most of its energy through radiation. About 50% of the energy in your body is lost to radiation, and that would be thermal radiation. Obviously, we don't glow in the visible spectrum. None of the light that we put off is visible. The only reason you see people is because light is reflected off them. But if you had infrared eyes, you would be able to see them, not because of reflected light, but because of light that they actually give off. And so this is an infrared camera. These two British guys, or Australian guys, or whatever, they're looking at a refrigerator, but also notice how their bodies appear in this infrared camera. So you can watch this short clip here, and just think about how different objects appear at different wavelengths. So warm bodies appear bright in the infrared. Stars, on the other hand, which have a wide range of temperatures, can emit light in the visible, which is like our sun, it primarily emits light in the visible, but they also emit light in radio waves, X-rays, and even some stars emit gamma rays. You can watch this clip here. Here's a quick test for you. We'll pick up with this topic next.